Hey everybody, this is Larry, this is me going Q4 of the weekly contest 355, count paths that can form a palindrome in a tree. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. So this one I definitely was, I think this is one of those classic cases, and this is, if you've watched this before, usually I do a post-mortem of how I think about this poem first, and not necessarily, just describing the poem. So feel free to fast forward. I don't know why people always, not a lot of people, but some people leave comments on my comments saying that, like, they wish they could skip it. And you know what? You have the technology. Fast forward, skip, whatever. You can even skip what I'm saying now. It's fine. I believe in you. In any case, so I actually did not solve this during the contest, unfortunately. I spent an hour debugging certain things. I don't know if I would have gotten right if I got it, because it's very tricky to do. So my problem with this particular one was that I was trying to do this technique called tree rerouting, which isn't that bad. And I think technically speaking, it is doable. It is just very, implementation heavy. And I definitely messed up the implementation at a couple of points. And that was basically why I struggled a bit. And I think I could have gotten it if I didn't waste that much time, even though the code would have been ridiculous, maybe even times out, to be honest. But if it doesn't time out, then in theory it should be right. But what we're going to go over today, though, is a more beautiful solution that a lot of people found with an observation that people did. But I think, I didn't figure it out. I think sometimes, and I say this a lot of it, maybe hopefully to a future Larry who might learn from this, is that sometimes I do get a little bit tunnel vision. I know there's a path to solving this, but maybe there was a easier way. But I just was like, okay, let's just grind it out, let's just figure it out and then do it. And I thought I was very close many times, but I didn't end up solving it. So yeah, but it is a very tough and tricky nuance, because sometimes I go the other way, where like I spend too much time trying to think of a easy solution when the hard solution is just hard, right? So you just kind of do what you have to do. But let's go over the beautiful solution first. So there are a couple of observations to make here, one of which I missed, but we'll go over the easier ones that I didn't miss first. And the thing about this is that we're trying to keep a palindrome, right? And here is me trying to bring up the drawing, so hang on. So basically the idea, what is a palindrome, right? And there are a couple of problems that are similar to this before, so I think that's why I kind of did it probably in a similar way. This is just a random tree with some, like, A, B, C, A or something, I don't know, right? And the idea, so what is a palindrome? So for me, so you can do it so the way that I did it with rerouting is just, and this is a binary tree, it doesn't have to be a binary tree. So let me actually just draw another edge, right? The idea is just keeping a count of all the possible paths. And remember, in this particular problem, the order of the paths don't matter, it's just what composes on the path. And and because you can rearrange to create a palindrome, what does this mean? So a palindrome means that in this particular, in a more generic sense, a palindrome, let's start with this, is that, it has, one observation is that it has even number of every character except for one of them, the one in the middle. But because we can rearrange, then it becomes the total count of each character, as long as almost like pairing things off, and then do it that way, right? And because of that, then now and I'm going to explain the rerouting first a little bit, or not the actual rerouting, but the idea behind rerouting is that, okay, so that means that, and we could take any node, not just this node. I mean, we can start from the root, but we can actually take even this node, right? This node, we can say, okay, let me change the color real quick. Going this way, we have 1B. Going this way, we have 1C. And then now, recursively, we can calculate this, right? This way, we have one path that is 1A, we have 1A, 1B, and then 1A, 1C, right? Yeah. Right. And of course, like I said, yeah, it can go many each way. But the idea here is that, okay, let's say there's a palindrome. We just go for each node, we calculate how many palindrome passes this node, right? And the way to do this is just, you know, let's say on this path on the left side we have these 3 things. That means that, okay, so the 1A has to match with 1A. So that means that, is there any path that has 1A here and 1A here, right? 1A, 1B has to match 1A, 1B. 1A, 1C has to match 1A, 1C. Of course, these are perfect matching, right? So we didn't go over the case where the palindrome where you have an extra number or extra character that's in the middle. And of course, actually, you can just brute force this, because you can say, okay, well, what if it's 1A and then you know, you have 1A and then there's an extra thing like 1D or something, right? So you look for that. How many 1A, 1D is on the other side? 1A, 1F, 1A, 1G, dot, dot, dot. So that's basically the core idea about this, is that, okay, so you have all these branches of a tree and you try to match the left and the right, or in this case, as many different branches together so that they kind of combine to even number of each character except for one of them, in which you can brute force what that one character is. Okay. And you can certainly do this with rerouting. It's very annoying. I didn't solve it in an hour, and I had an hour to do this with rerouting, and I couldn't get it. Implementation wise, it's very tricky. I mean, some of it is my limitation, not just rerouting, but you know, I'm just explaining that way. One observation here is that you can actually store this as a bit mask, right? So the 1A, 1B, as we say, so 1A, 2A, and then so 2A, we can actually just cancel them out, because, you know, you can, even if you have an actual palindrome, you could like ABA, you could even just pretend we cancel this and cancel this out. So then we have 1B. So this kind of makes sense. And as a result, you can use a bit mask. A bit mask is just a boolean of a vector of booleans. So now here you have 26, you know, up to 26 characters. So you have F for force, dot, 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 all the way that translates to 0, 0, 0, dot, 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 dot. And then the T's, the trues, will have ones and so forth, right? And so you may wonder, you know, 2 to the 26, is that too big? Well, there is not that many possible paths, right? There's only n squared paths, so, you know, in theory, maybe that's the thing. But there's actually another observation that we can make, which is this beautiful observation that I did not make, right? Hopefully you're following so far. If not, then maybe rewatch this part, because I think it's important to understand. But basically the idea is that you want to match, you know, different paths of the tree, saying, okay, how many palindromes passes through this node? And the number of palindromes that passes this node is just one branch having, you know, matches the other branch. And in implementation, we can talk about it, but yeah. So what is the observation, right? The observation is that, so basically, if we're doing the rerouting, right? So rerouting, you basically, let's say we're on this particular node, we calculate all the branches, and then we kind of combine them in a way such that, you know, in every permutation. And there's some ways to do this in a good time, but you want to combine them in a way such that you calculate how many palindromes go past here and here in this subtree, right? Let's pretend this keeps going on, right? I didn't draw it out, but let's pretend it goes on, right? And then the rerouting part is that now you have to calculate stuff that goes in with the root, right? So then now you also use this to calculate with respect to all these other stuff, right? And, you know, it's a calculation there. But there's actually, it turns out, a easier way. So the easier way is noticing that whoops, press the wrong button. The other way is noticing that actually you don't need to, you know, you don't need to do the rerouting. All you need to do is just count out all the characters that you have seen so far, and that is good enough. What do I mean by that? What I mean by that is here, let me change colors again. Hang on. Let's say we go here, right? So at this particular node, from the root we have 1A. From here to the root we have 1A, 1B. Here we have AC. Here we have ABA, which we cancel out, so I'll just write B. And here we have ABB, which we cancel out, so we just write A, right? And so then the question is, well, so of course, ready, and you just keep track of how many counts. So the naive explanation is that, well, obviously, if we count it from here and we go all the way here, then obviously we just count everything to the right. But how does this work if you kind of just modify a little bit? How do you modify it so that you calculate palindromes that don't go through the root? For example, actually this is a palindrome, right? Like here going here. So we want to go past here. Well, that's the beauty of using these bit masks, is that using these bit masks, so the path that goes from here all the way to here, and the path that goes all the way from here to here, if you sum up these paths with XOR sum of these paths, actually these cancels out. Because these cancels out, then now you are able to get just these using this to here. And that is the observation that a lot of people used to get it in 10 minutes or whatever, like a very quick solve time, because using that, basically the path cancellation, if you want to call it that, from the root, which I did not get during the contest, you're able to have a very beautiful and clean solution in, So hopefully with that visualization in mind, we'll go over this. I submit this after the contest, not this one. Yeah, I submitted this after the contest. So yeah, but the idea is basically now, and you don't even, you keep track of the mask, and the mask is, as I said, is a bit vector of all the characters we've seen so far. And here we go, okay, how many of the same things that we've so far? So if it's exactly the same, it means the number of paths that goes all the way up to the root and here and is exactly the same. And it doesn't matter where it cancels out, right? I think that's kind of one of the things that I took me a little bit of time, is that if you have a path that goes here, I have to draw it. A path that goes like here, it doesn't matter, and it has 1A, 1B, 1C. It doesn't matter where this is, right? So let's say this is also C. Let's say this is also B. This is also, and then this is another C. You count all these paths together, because basically because the A's cancel out either here, or A and B cancels out here. So then here you have either this path is good and this path is good, and also maybe all the way up here. And they all cancel out. And if you look at the code, and if you don't have a deep understanding of this, it's actually kind of like ridiculous. It took me a little bit of time to figure out what it meant, just looking at the code, and you can watch me actually learn this live as I kind of read the code without any help. But yeah, so this is what it matches. And here is just the brute force of, okay, let's say, so this is the even length one, so everything matches perfectly. This is the one where it's odd length. You have an extra A, you have an extra B, you have an extra C, ... And then you just keep a counter. And then after that, you just brute force recursion from the root. You just say, okay, you change the parity of character C. We have an extra one of these, so let's go check that out. And that's pretty much it. Very beautiful code. Linear time, linear space, because this is linear space, because even though you can say there's a bit mask or whatever, but counter is the number of paths from the node, right? And the number of paths from the root to is, well, just n, because there are only n other nodes, n minus one other nodes, and they're all traveling from the root. So yeah, so linear time, linear space, and I guess you could say O of alpha times And because because we only do one recursion, there's no memorization. You don't really need memorization from here. And here, like I said, it's going to be at most linear other things. So yeah, that's all I have for this one. Let me know what you think. Let me know if you have any questions either here on Discord on what I can explain better. I think one thing that I will request is that people just keep saying like, oh, you should explain more. Maybe it'll be clearer. No, you ask a question in a way that enables you to, otherwise I'm not going to like fish out the entire ocean of possibilities. But, if you are able to ask a question, be like, oh, I have this example. I don't get why for this example what you said is true or something like this. Then we can walk through it, and in the future I could preemptively do that for my videos. Anyway, that's all I have for this one. And yeah, you can watch me solve it live during the contest now. All right, YOLO. Let's give it a submit. Huh. So I had the right idea apparently, but I just kind of implemented very stupidly. Okay, I mean, now we just have to get Q4 and we're in good place. I can't believe I implement that one. Let's go. Q4 focus. Give me a tree. We did at 0 with n nodes from 0 to I minus 1. 0 index, parents of I. Okay, so you're given a string S, where S of I. Zero can be ignored. Return the number of pairs of nodes. I didn't even read it. Okay, read it. Focus now. 0 index array of parents. Okay, so you're given parents, so it's a functional array, or functional tree, or a functional graph. So 0. Okay, so you're given a string of length S. Okay, so it's the edge between the parents. Okay, return the number of pair of nodes such that the characters assigned an edge from U to V can be rearranged to form a palindrome. Okay, I think I get it. How am I doing on time? Top 70. How many people get Q3? I think it's just not updated. Arise got Q4, so good for him. Okay, focus, Larry. Stop. All right. So all pairs 0 or 1. Okay, so yeah, one length things are always good. 2, 3. The pair 2, 3 ACA, which is a palindrome. 3, 5 could be a palindrome. Okay. Palindrome is tough, right? Okay. I mean, I think I know how to do it, but it's still tough. Do I know how to do it, Larry? I don't know, actually. Maybe not. Okay, but I have the idea about it. Okay, fine. All right, let's just construct a tree. We have a parent. For index parent and then rate parent. This is obviously not right. Year of P dot append index. Right. Okay, then we're good, and then we want to just go from 0. So okay, just go to go. The other thing is just as bad. Okay, so we have a node. Do I know how to do it? Maybe I lied. Because there are all these possible. Is there? No, there should be at most n possible paths, one for each node. So then it's n squared for the combined? No, because then you could do a lookup. Okay. Yeah, okay. Go. Okay, so then now we want to recursively go. Okay, so left is equal to go. Huh. It's not a binary tree. That's the how they do functional. I still know how to do it. Okay, I just have to. Okay, fine. The palindrome part is kind of annoying there. Okay, so the node doesn't contain the edges. It's from the. I mean the edges. Okay, think that you got. You know how to do this. You just have to be careful. Okay, so from x in node, go x. Right, so we're going downwards. Okay, I think we don't go upwards on this, so that we should be fine. And then so basically, right. And then basically now for P in paths, and this is going to be a pit mask. Yeah, okay, so here, so for P and paths, so path is a bit mask, so then we have to look up a P, we increment by 1, but before that, we want to say something like, yeah. So okay, yeah. So oh yeah, so then we just look up total. We want to add this by lookup P, and also we want to. So that's the thing, and we also want to. So that's the parity, and then for I in range of 26, total to look up P to on I, right? Okay, and then yeah, maybe. Well, no. So these are all the paths. The P should be with 1 to the I. S sub node is the character, and then we want to convert that to right. Node. Right. So this, that's the path that for X, and then we kind of go. This is the transition, and then this. Okay, right. And then we also want to kind of just right, and then we return. Or maybe okay, fine. For so then all dot append P and then we return all, right? And then yeah, that should be good. Return total. Okay, well, P. Oh no, this is wrong. This is, we need the extra thingy for the counting. Okay, still wrong, but oh, I don't have a base case. That's why. So let's let's refactor this real quick. So I don't have, I don't know if this is good, but okay. Another base case. Is that true? Oh yeah, I don't, because I don't return anything. So otherwise this return all, we return nothing. So we return 0. Is that true? 9 and 6, that's really wrong, but definitely wrong in a couple of ways. So we definitely want to do this is weird. The way that I did this is wrong. This is wrong. This is wrong. This is not the right current. That's why. Because basically here is actually okay. So that is the actual current. Because that's the path going to X. Oh. I don't know why I need that though. Okay, still not right, but maybe that's slightly better. Oh, I'm missing order. Okay. So basically the paths are this is wrong. How do I do the base case correctly? Okay, so current right? Because it's not on the node, that's why it's a little bit. I think this is maybe right though, but I don't know how to get that in. Because paths don't ever return anything, because I don't like the way it is constructed. What is the base case? So okay, so you have a node, you return nothing, and I think is dot append this. I think that's what I need, and that's what it should return. Okay. Sure. And then because of this is also a thing, then we increment by 1. That's not good. I don't need that for anything. 6 and 4. Okay. Creating that one edge, and then for every one of those, we append this with the new character, right? It's something like this, but I'm really slow on this. Like I'm close, but not quite. What am I missing? Let's just print things out. Print node lookup. This is actually pretty bad. Wait, maybe not. So 3, 1, so 1, 2, 3. So this 3 has nothing, 4 has nothing, 5 has nothing, so that's fair. 3, 4, 5, but then 1 has 3 and 4, so this is wrong. One has 1 and 2. Yeah, so that's an A and a B, which is true. And then total is 2. Okay, so that's good, possibly. Maybe, I don't know if that's true, because this is wrong. Because basically 4 should not have anything, right? Four should return. Yeah, why? No X. What the? I should have gotten this already. It kind of annoyed me. Okay, so 1 going to 4 is 2. Why is 4 giving me 1? Why is 4 giving me 1? 4, 1, 3, 1. Okay, so 3 got 1, 4. What am I doing? Well, the edge thing is kind of confusing me, I think. Okay. So, okay, so the 3 counter, nothing is good. And then now it goes 1, 3. Oh, and then it adds 1 on the 3. I guess that's fair. From 1 to 3 and 1 to 4. And then 0, 1. You add 1. So that's 3. Okay, so I think we're good up to this point. And then 5, nothing, that's good. So 2 to 5, we also add 1, so that's good. And then, yeah, and then we return. And then now 0, so 0, 1 is 1 and 2. Right. Did I mess this up? Why is that 5 and 6? Okay, so okay, I think I know what to look for now. But okay, so X paths. Okay, let's do it that way. Zero, 1 is 1 and 2. 0 and 2 is 4. That's wrong. 2 to 5. So I do have to 2 to 5 is a C. So this is wrong. Oh, no. This is R. What I want is R. All right. So 2 to 5 is a 4, which is a C. Okay. 0 to 2. These are some duplicates here too, but 0 to 2. 0 to 2 and R. I know why, because paths is it's not a thing. Actually, we have to return lookup, and then now it's a count, and then now was every time paths. I 7-4. Am I better? I don't know. I'm so bad at this. Okay, so at 1, we have an A and a B. That's good. Let's see, well, one, there's an A and a B, but that's just this prefix, so it's not done yet. So 0, you have what's 5, 1, and 4? So A and a C, that's right. A 6, okay. So what is 6 again? I mean, I'm confused again. Of 6 is 2 and 4, so B and a C. So that's right. That's right. So what is wrong here? So 0, 1, you have 1 and 0 to 1. I don't know why I have to keep scrolling up and down because of this interface is so bad. Okay, so 0 to 1, you have 1 and 2, which is not true. So 1 is returning this, but 0 and 0 to 1, oh wait, this is good. And then we'll do lookup. Right? Yeah, so then now from lookup it's 1C, CA, and CP. Okay, so that's right. I should have had this already. I'm so lost. 0, 2 is 4. That's definitely not right. Oh no, that's what it's returning. So then after update is this isn't quite right either. But I'm not double counting. I should be double counting, but I'm not. Yeah, okay. This looks more right, but man, I'm so bad today. 0, 1 plus 6, right? 0, 2. So the 5 would. Oh, this isn't. Is I see. So basically, this is perhaps a P times this. Okay, well, and this is this total 1 then? Is this total 1 of? Oh, is that? But no, that's the edge. Should be maybe right. Oh, I have to look. I see. Okay. I think I'm doing this really sillily, in a silly way. Okay, and then now I don't need this. I just need this. Oh, this one I need that. Maybe. I don't know how to do this anymore. Why is it not returning anything anymore? Focus, focus. Oh, this is just weird. I don't need that many new paths. So we have a lookup and then we return lookup. Why? Why is it not doing anything? They should at least do something, even if there's nothing else. I feel like I'm so close, but I'm so bad. And I guess in this case now it doesn't matter because how we do it. Okay. Maybe I did something funky, but all right, let's get this one. Maybe this one's a little bit easier. Okay, so what is the AAA one? Okay, so it's just no AAA, right? Yeah, I think I should just return it with that. I think I did it the wrong way, but okay. One is I think this is doing a lot of the work. So lookup of P is 0 is Y. That makes sense because this lookup is new. And okay, I think I'm just being dumb. So for every path that we get, I'm being dumb. Okay, for every path that we get, no, I think this is right, maybe. But how am I fixing it? Lookup of P, lookup is fine, but the paths is wrong. What are paths? Look at this one. So 0 to 1, the paths are empty. Why? Tell me why. Because I incremented. P is always empty because we did this stupid thing. I am dumb. Okay, that makes sense. I mean, okay, so I need to do that. Look up. I think I messed up with my yeah, okay. I confused myself a bit, but look up. So the path. No, now is. Oh, Larry, what are you doing? Why is it so bad? Okay. It's bad because look up of increment by 1. We also want to count this one, I suppose. This is a little bit off though. So 2 look up total 0 to 1 is that's actually right. This is actually right, but it's not adding correctly. Well, this one maybe is good. What am I doing wrong? I'm struggling so long on this, and I knew how to do it, but I just don't clearly not though. So 0. Wait, what? I don't even know anymore. Why is there only one thing? From 0 to 2. Huh. Somebody's just. So we're not doing this loop at all, because everything is now returning a paths. Why not? This is returning to. There's no node. Okay, so I am. So then it just returns nothing. Okay, so this returns nothing, which is fine, but we have to. So this should be returning nothing, and then not to, oh, this is nothing. We increment by 1, and then we set up 1. Oh, Is that it? Because it matches the other one. Okay, I'm being dumb on this one. But it's still not right. It's better, but I'm missing something. Oh, yeah. How people doing? I guess people got a lot of it right. Okay, so this is right, I guess. Because now it's looking up if there's one more thing matching the other thing. So this is the one. I should have wrote this a different way, to be honest. Maybe I still can, but okay, so 0 going to 1, 0, 1. The path is 2, 2. The P is the path coming up, and then lookup is all the stuff that we previously seen. Okay, right. That part is right. Maybe this part is mixing it up. Yeah, I think this part may be mixing it up. Alright, let's say we don't have this. Is this right? So we have 6 because we have 6 nodes. So, well, no, we have 5 nodes. And then one more thing that makes it a 6. So maybe that's just off by 1 in a stupid place as well. 1, 2, 3, 4, 5, because there were 5 edges. How do we get, what happened to the 6? Oh, actually, I guess ACAC is the 6. Okay. So that means that we have to figure out how to, okay. So maybe I did this the wrong direction. So and maybe this as well. But I don't know that. I mean, it's not right enough. So basically, it's saying, oh, I see. I mean, I think this is right too, or like this needs to be a thing for it to be right, but it is not changing enough. Why is it not changing enough? 2 and 3, so it should match. One and 5. That's 1, 2, 4. So 4 with 5. Alright, so 4 and 5, so something like this with, okay, so 0, 2, zero, 2, 4, and 5, okay, so the path is 0, 2, the path coming up is 5, now the coming up is 4. Wait, is that right? Oh, no, yeah, it should, well, yeah, okay, so it's 4 because it doesn't count A yet, so that's 5. Okay, right. And then now we want to do, we want to minus an A. There's so much debugging. Okay, so 0, 2, 4, and 5. So it added 1, but it should have added 2. Oh wait, no, that's not true. Is it? ACAC? Okay. Yeah. No, it should have added 2 and ACA. So A means that the path should have been, okay, from 0, 2, the path is only 4, but the path should also be here. So, okay, so we have to add, so C, we have to, okay, I see. I thought about this, but then I guess forgot, because I've been so many things wrong. What am I writing? So the path that came up is going to be 1. Oh. And then now this is this times lookup of P. Is that right? Oh my. Okay, if this is A, we want to say if this is A, I can't find. Okay, so then this is 2. And the path is the thing that we get back. We don't hear about the path. We just hear about the lookup. And we cared that, yeah, I think that's it, really. Okay, maybe that's too much then. Now, I guess this thing now no longer needs the 1 length as Y. Okay, still wrong. Why? Tell me why. Because A. Do I have? I'm trying to say that there's 1 unique character. Why is this thing? Oh, this is just dumb, Larry. Okay, 6-6. It's not great, but I'm so bad at this. I've gotten it, but I feel like I know this, but I'm just so bad at kind of merging all these things together. Okay, let me. I think the way I wrote it was really bad anyway. Okay, fine. So. Okay, let's call it. Let's just rewrite this. I think the way that I wrote it is way bad. Now we don't have to do this case if I do it correctly. But then what I want to do now then is then I just do. Right, and then now what I do? No, that's right, that's it. Right. Oh, this is the current, right? And then now look up, and we just write it over for x and with our paths, p in paths. Okay, in previous. I think I mixed up previous and current actually, but yeah. So then now is this plus -1, just to, because then now I just don't count the one edges. Okay, that's really wrong. So maybe not. I thought that would be closer though, because I definitely do not keep track of the thing, but is that too much? Yep. Okay. I feel like I was so good, but I know how to do this one, but I clearly am missing some like random weird HKC things. Okay. All right. Okay, so 0. This is way wrong. Oh no, this is the previous one. This is very wrong. Oh, this is this dot plus. Okay, so, but still very wrong. Tell me why. Okay, 0 and 1. That's not quite right. Oh, geez, Larry. Okay. Is this better? I don't know. Still should not have a 0 though. Oh, that's because this is a -1 or something. What is, did I mess up something? What is a of s sub 0 is nothing or something? S sub 0 can be ignored. Okay, fine. Okay. Look up. Okay. That's not right, right? No pre. I've spent like 20 minutes on this. Okay, so this is right. So, oh, I am dumb. Okay, at least now it's returning the right things, even if the answer is not right. Okay. How do I even get 7? Where does this 7 come from? Alright, let's go. We have to do it this way. 0, 1, that's already wrong. Oh wait, that is it before we add? Well, that's before we do the one edge things, I guess. No, this doesn't make sense. Why? What is this? This is for going up, right? So we add the count, but it doesn't add the total. So why is this not right? Why am I wrong? Okay. Or like, why am I like lagging behind? So the previous, this is gonna be nothing, right? So we return nothing, maybe? Okay, right, that's true. X could do 1, right? Why does this return? Oh, 0 to 2, so 2 returns none. Am I sharing reference in some weird way? I hope not. We don't look at previous, okay. Why is this returning a 1? I think that's the better question. Oh no, it's just that this other thing is adding. Alright, let's fix this first. It's gonna be 1. Okay, so this gives me the right answer. So then it's just the odd, weird things. Man, why am I so bad? No, okay, so that all these counters are right, except for previous and current. Oh, this is maybe wrong now. So it's the number of ways to do it previously and current. Wait, is it though? No x. Previous. Okay, previous and current, so this should have 1, right? So yeah, why is this returning to oh no, this is just returning 0 because it can, and then now when it goes to 3, maybe that's just right actually, maybe I just kind of missed reading this. But then now where am I going wrong here? Alright, 0 to 1, that's 5, 6, 4 is 5, right? 0 to 2 is 5, 6, right? So yeah, what is the total so far? So that means that we added 5. Okay, 5 matches to 5 is 2. Okay, 1. So that's 4, which is actually remarkable. But how is that even true? Zero 2 should not have a C. Okay, so this is actually, is this right? This is not right. This is not right. Is it right? No, this is right, but why? I can't believe I cannot get this. I was so confident about this too. 0 to 2. Oh, wait, this is just the aggregate of things actually. I think this is fine. 0, 2, current. No, we want the previous. Okay. Okay, so 5 and 1, that's true. So then now, how are you adding, how are you adding to 7, dudes? So the 2 paths, is that even true? 0 and 1 somehow adds 2, 0 and 1. I mean, I think that's actually right, maybe? I think there's like a thingy here for adding an edge, but that's not even right. I cannot do. Okay, spend like half an hour on this debugging, even though I know how to do it conceptually. Okay. Okay, so why is this adding? This just like 2 things. There should not be 5 things. Maybe I just don't know how to do exact things. The odd number ones. Maybe I just don't know how to do odd number ones. But okay, so how do I do an odd number one? Let's say the current path is A. We want to say is that right? No, it's still off. Basically, okay, so you have for each path, so you have 5 and a 1. The 5 you have A and C, so you want to get rid of the A, right? And then 4, so the 5 we match up to 4, which is fine, so that's 1. And then the other thing is if we get rid of the C. Oh, I see. This double counts if I do. Okay. Is that right? That means that, okay, with an AC, we just want to match. Okay, so if maybe something like that. It's still wrong though. Oh, wait, I did it that way, I think. Okay, so I have to say this way precisely. Okay, so this part is right, it just matches left and right. And then now this is saying, okay, for every character that it is thing, then count this and then the count on the other side by getting rid of it. Okay, so getting rid of it. C and it is fine. And then C, so then you have 1. But then we're undercounting okay, so I guess we can add no, so this isn't quite right. So I think this should be good. Why is this wrong? 6 6, right? Because this gives me this double count something. Oh, because of the path of 1. Okay, so that means that if P maybe? Because I'm double counting single paths, but oh, what am I doing? Okay. So okay, so now we have AC and then an A, right? So that's on this side. AC and so the CA, we want to match CA, that's fine. We want to match just the C, so we have to take out the A, which is true. Yeah, and that's fine, we had it. But then the A, we want to add a C, but not AC adding an A. For an A, we want to add a C. For an A, we want to add a C. But we also want to take out the A, which doesn't make any sense, but I guess we can just do it anyway. I guess I'm not solving this one, even though I'm so close, I think. I've been close for like an hour or so. Okay. Right. Okay, so 5 and 4 on the 2, on the 0 to 2, right? So 5, and then the 4 is a C, so that's true, right? And then 1 and a 5. Oh, because I add current, so then I'm matching it with itself. Oh man, is that it? Oh man, I am an idiot. I took that out for a while. I mean, yeah. This part is hard. Not being an idiot is hard, I guess. I have another print statement somewhere. Where's my print statement? Oh, right. We may still be wrong, but at least we're a little bit closer. With 9 minutes left. May time out. Maybe it's a Python thing, and I did all that time for no reason. Okay. I mean, I feel like we're close, but okay. So, we have a node. Zero. All right. So 0 is 2b. And then I had to draw this out. This is ridiculous. And then a Q, which is 5, right? Wish I had more time. And then you have a SQQ. So the answer is 5, or the answer is 7, but we get 5. Okay, so SQQ. Okay, so there you have 1, 2, 3, 4, 5. Okay, and then you have QQ. Oh snap! I didn't do the going. Yeah, I have to do the rerouting trick. I mean, I know how to do it, but I did miss this case. I was thinking about this actually, but it's too late now. I don't think I could fix this in 7 minutes. Really should have gotten it though. Like people know how to do this. Q3 is the harder one apparently, but maybe not. I don't know. Maybe I misspoke. But I have to do the rerouting thing. Yeah. I actually forgot about the rerouting. Because I was trying to debug this for a long time. If I had time, I probably could have done it. Probably need to upsolve a bit. How do I reroute this? I actually was thinking about this. Poop. But then I just kind of lost track. Yeah, I don't think I could fix this quickly. I spent too long on this silliness. Let's see if I can upsolve it. Man, I can't believe I spent so long on that typo. Well, not typo, but I fixed this previously, but then when I rewrote it, I messed it up again, and then yeah, I mean, I don't know how to do it in an easy way, to be honest. I mean, it's not that bad, but I feel like I'm a little bit behind on how to do this. Okay, so I mean, I could do it. Maybe it's a little bit too late. I don't think that changes anything, but basically we want to look through all of these. So now we have all of them. So then now we want to look at this guy. And then, okay, maybe I could get it. I don't know. I mean, I don't think I could get in 2 minutes, but maybe I'll still get it. If I didn't spend so long on debugging, then okay. So now we want to previous of p of this is just going up, so it doesn't matter that much. Wait, is that true? Wait, what am I doing? No, I'm confusing myself a little bit. I'm not at the parent, but I have to also get all the previous paths. I mean, maybe I can just write another one, but that's fine. Right. And then too slow, but yeah, and then but yeah, okay, current is equal to node, right? So now we have all the things, so we want to pass it down to for, yeah, I mean, I think I could have gotten it if I had. I don't know how people got it so quickly though. People, I mean, I think I have to practice rebooting one. Okay, yeah, let me, contest is over, but I can't spend too long debugging that thing. But I'm going to figure out how to. Okay, so we just something like this, right? So here we want to do maybe yeah. Basically now, what do we do with scene? Right. This isn't quite right either. No, this isn't right. Well, this part isn't right, maybe. But basically, okay, so starting from the root, you have everything, so you basically subtract out so then you subtract out all the things there. Yeah, okay. Sure. Every problem you can solve is not tough. So please, when someone tells you it is hard, don't that's it, please. Trying to think of a second. Where did I end up anyway? I mean, I didn't get Q4, so maybe I'm just doing this weirdly wrong. Maybe I got stuck in this mindset. The rebooting thing is a little bit. I mean, I got practice the rebooting thing. That was something that I knew I was weak on. So yeah. Now I'm still doing a hack. Alright, maybe I'll cheat a little bit and kind of just see how to do it correctly instead of reproving myself. Because people got in like 5 minutes. It should not be that hard. I mean, I don't know. Let's see if we can learn something from it. It's crazy. Because people got it pretty quickly. Okay, so you have degrees. Topological sort. How does topological sort even work? Okay, this is just finding the root, I think. Which I guess he missed the fact that the root is always 0. But or maybe I'm just misunderstanding. Maybe I'm misunderstanding this. I don't know. How does this even work? Maybe not. Maybe I'm wrong. How does this topological sort thing work? Alright, let's look at another one. I mean, a lot of these looks like mine, but I feel like I missed some stuff. Alright, let's look at something less verbose. Alright, adjacency list, TFS. What is we? Maybe I just did it in a funky way. I don't know. Yeah, maybe I did it with the leaf thing. So, okay, let me play around just for a second. What if I did a thing where I keep the bit mask from the root? Do I have to start from, no, we don't have to start from the root, right? Okay, so what does this mean? Let's say I have a mask of things we've seen, right? So I don't know if this helps, but okay, so for mask right, I don't get it. I don't think this is quite right, right? I don't know. I don't. I mean, this is just DP, but maybe I misunderstood some stuff. I get what they're trying to do, but I just don't get it. Okay, let's step back for a second. Okay, so now we went down, and then we want to see. Where's CNT? What? That's just unnecessary, but okay. So basically, we want to see how many of this we've done before. What does this do? This doesn't do anything, right? I think maybe it just... There's a very weird code. And I know how. Right. We want to add mask, but why does this work? No. Or just calculate code. And they're saying that this works. Maybe today is just not my day. But I just copy and pasted really. But okay, let me think about this. So basically, you're counting the. I think the thing that I don't get is how do you count? Oh, I see. That's a very clever observation. I don't know that I could see. Before that. I see. Wow, that's a hard one. I mean, mad props to people who got it. I get it now, but that's actually that's beautiful. I mean, it's just so hard. It's beautiful. No, this is. I thought there was like a rerouting thing, so I was way wrong. Apparently, I was down the wrong path. I don't know what. I guess it's just. Is this iOS? Did I click on it? Oh, I did click on it. There's a weird way of doing it, but okay. Proceed and results. The way that Alex did it is kind of actually ridiculous, but yeah, I could explain it now. I mean, that is an incredible observation. Yeah. I see it, but wow. That's kind of hilarious, but see in results. Wow. Could I have gotten, I don't know. I think I could have gotten it in a very difficult that and the annoying thing is that more people got Q4, so my Q3 didn't really stand up. Maybe that's not true, but Q4 is worth more. So even though I got Q, you know, but Chi. That is a beautiful observation, actually. But yeah, and what do I mean by that? Definitely check it out. But yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. A pretty hard one, right? And on this forum, yeah, let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.